Hi and welcome to my first video devlog. This one's going to be about Unclick Debugging. It was a bit hard, but I'm just going to go through the whole process and what I needed to change to make it work. So first up was a bit of cleanup. I had to make a C++ map to to basically neaten up all my game objects. So instead of doing g.gameObjects 432, all I needed to do was the map and call a name, and now I get all the properties of the game object. And I actually made a header file here called GameObjectList. It's just a map. I just did this so I can access it universally throughout the whole program, and instead of just main.cpp. And then I made a new C++ vector in game.h. Whoops, game.h here, over here, and this is also so I can just access it through the game, so it's a bit more neater. And what I need to do to push it to the map is for every mesh here. So let's take the paddle 1 mesh. I insert it, I get the name, and I had to make a new global variable from the GameObject.h called name. So each game object has a name variable and a reference to the game object. And I basically just did this because it's way easier and it changes dynamically if the person decides to change the name of the game object itself. Um, Next up would be bounding boxes. So I had to make a bounding box for each important mesh, GameObject.h here. So a new variable for all game objects. It's a vec4. It's called bounding box, which is, as you guessed, a bounding box. And I created a new function called create bounding box, which is also vec4, of course. And it's not the best way to create a axis aligned bounding box, which is it doesn't rotate. It just what it basically does is the most extreme part of the bounding box, like the most extreme to the right, will be the most extreme right vertice of the mesh. But that would take a lot of process, and I had to go through the model matrix and basically try to re-render the whole thing just to get the right vert placement. So what I just did is a quick and easy calculation. I take the position and then add the scale or minus the scale, and yeah, basically from right, left, up, down. And to check if the mouse has collided with the bounding box, screen.cpp here. Basically that simple. If x position of the mouse is smaller than the most right of the bounding box, and all the other parameters here basically same vice versa, return true. It's a Boolean function, and else return false, of course. And also next I had to not translate, but convert the mouse or screen coordinates to game coordinates. Game coordinates are usually 0 to 1, but in my case, since I had to scale up everything because of mathematical errors, I had to go from 0 to 100. It's not really of a big issue. Here you can see it right here. I had to go through a lot of guides to get the correct calculations, but here's one that worked for me over here, and this translates it, this converts it to 0 to 1, and then I just times by 100 so I can to fit my current world coordinate system. And then after that we go on to the Unclick Debugging. And before we go into here, actually, I had to change a few things with create debug menu. So and you can see what it looked like originally with my blog post. It's in the archives on my blog website right now. And the parameters changed from just a game object to the game object list and the name. What I had to do here was just basically make a temporary game object by using the goalless name with the at function that the map usually the CPP maps usually have. Well, not usually, they all have them. And it's basically the same except this, so it's more dynamic and it's way easier to just call a name and have its properties show up. And for the on-click debugging here, we have an if statement checking what scene it is. If it's not a game scene, it won't work. And I made a state which will get the state of the left mouse button. So if it's clicked, if it's released, and all that kind of stuff. This basically gets the cursor position of the current cursor position, then translates them to screen to world coordinates, and then this is actually for debugging. It's not actually important. Here, if the state is pressed, so if the left mouse button is pressed, we go through all the game objects here, and I made a boolean, which is from the collision BB, which I showed you. It checks if the mouse is colliding with one of the bounding boxes. And then I have an if statement here. It checks if the name is empty. So particle systems and power-ups are also game objects, but they don't have names. So if you try to hover over them, it will cause some really weird issues with the create debug menu. So we just avoid this altogether by doing this check. And then if mouse intersect is true, we print out the debug screen here. And currently I'm working on making the debug screen stay after you click it, but currently it just shows up when you click it and disappears when you release. I'm probably gonna make a new devlog when I implement that, but let me just show you quickly the Unclick Debugging here. So now you can see that if you click on the paddle, it shows the paddle properties, click on the ball properties, and so on. And of course the bounding box follows the paddle, so let me just add a few more frames here. So here, if you click on the paddle where it was, of course, it's not going to show up the paddle properties anymore. But if you click where it is now, and it's going to show up the paddle properties. Same with the ball, same with everything else. And yeah, that's basically it. Pretty simple. And I'll see you next time.